Hi, here we are again. So the video of today is dedicated to the International Day of Women and Girls in Science, which will be this Thursday, 11th of February. Okay, so the presentation of today is dedicated to that day. Okay, so let me put the slide and we start. Okay. So here we are. So as I said, Thursday will be the International Day of Women and Girls in Science, and it's a very important day. I remind you, my name is Mariam.Cosmology. I'm a researcher at ICAR Basque and a lecturer at the University of the Basque Country in northern Spain. Okay, so what is the International Days of Women in Science and when it is? So as I said, it is the 11th of February. And it was established back on the 22nd of December of 1915 by United Nations. Okay, so essentially this year is the 6th year we are celebrating this day. And why is this day so important? So it is important because it promotes full and equal access to participation of women and girls in science. This has not been the case historically, and still up to nowadays, this is still not fully the case. So there is still a lot of work to be done on this sense. So science belongs to everybody, women, men, girls, and boys, okay? So we need to work in order to enhance and to promote, as I said, full and equal access to participation in science of women and girls. This day also recognizes the work done by many, many scientists, okay, women along the history, okay, in science and in technology. And in general, it recognizes the critical role we, and I include myself as a scientist and as a woman, and girls play in science and technology. So on this short video and in this modest video, what I will do is try to make a contribute to all female scientists along the history till nowadays. The list is very long, okay? So therefore I had to pick up some scientists, female scientists. And given that I'm a theoretical physicist working in cosmology and gravitation, so my apologies if I'm biased, but I pick up 4 female scientists on this field. Other years, I will pick scientists from other fields, okay? So the first female scientist I would like to speak about is Emmy Noether. She was born in 1882 and passed away in 1935 after going through some surgery, okay? She was a German mathematician, and she's quite known for her huge contribution in different areas of math. In particular, she contributed what is known as her theorem. It carries her name, Noether theorem. But as I said, she contributed as well in other areas of mathematics, including algebra, for example. Now, Noether theorem is very important in 2 areas. On the one side, in all what's referred mathematical physics, and of course, for its applicability in theoretical physics, okay? What does Noether theorem tell us? And why is her theorem so important? So she was able to establish in a rigorous mathematical way the concept of symmetry, okay, and the concept of conserved quantity of a given system. So essentially, what she was able to do is having a system which will be described, for example, by a Lagrangian, okay, a mathematical concept. She was able to define or to say, if we have this symmetry, then we have a quantity associated to this symmetry of the system, and that quantity is conserved. I put there some example, for example, the energy. If the Hamiltonian that describes the system, okay, does not depend on time, okay, and the Hamiltonian again is an abstract mathematical object to describe a system. So if it doesn't depend on time, then the energy is conserved. okay, of that system. Also the angular momentum. So if we have the motion of a particle in a circular orbit, and such that the motion is uniform, then it's well known that the angular momentum is conserved. What is the symmetry in this case? So essentially the system, okay, is rotating around an axis, okay? And it doesn't change as it rotates. And that angular momentum, okay, is a vector, is an arrow. And that arrow does not change. The length and to where this arrow is pointing does not change as the particle is orbiting around that circle. Okay, so those are examples. Unfortunately, despite her huge contribution, okay, so after finishing her PhD, well, she worked for 7 years without a salary, okay, at the Mathematical Institute of Erlangen. Okay, 7 years working without a salary, with all her huge contribution to several areas of math and theoretical physics. Okay, it is also known that she never got the rank of full professor, again, despite her huge contribution. Okay, so here is a clear example of a woman in science that made huge contribution to science, and nevertheless, society was not fair with her. So that's why Thursday, 11th of February is so important, so that these kind of mistakes are not made again. Okay, let me speak about another scientist, Mileva Einstein. She was a Serbian mathematician. Okay, she was born in 1875 and passed away in 1948. Some of you might know her. Mileva was married to Albert Einstein. And well, she was married, she was his first wife, and she was married, as I said, to Albert Einstein in 1903. But she had to give up her study in 1901 when she got pregnant of Albert Einstein. Okay, so she gave up her studies for her future husband, okay, and for her sons. Well, it seems like she contributed to the first work of Einstein. From the correspondence she maintained with him at the time, it seems like, well, she had some contribution to on Einstein's first work, in particular on the photoelectric effect. So essentially, if we send a photon with a given energy, if it has enough energy, it might, that energy might be absorbed by an electron, and the electron will pop out, okay, from that material that we are targeting with photon. She seems like she also contributed to the special theory of relativity, okay. Who doesn't know the expression E equal mc squared? We see it in t-shirts, okay, and in books in many places. So that special relativity, okay. So it seems like that she helped Einstein also in this regard, and also with the mathematical formulation of the Brownian motion, okay. She was an excellent mathematician, and again, it seems that she contributed to the formulation of the mathematical formulation of the Brownian motion, okay. Now, amazingly, the photoelectric effect that she contributed, apparently she contributed to, okay, well, deserved the Nobel Prize that's of 1921 that was given to Einstein. Disregard meant that Einstein got the Nobel Prize for the photoelectric effect and not for relativity, special relativity or general relativity. And here what I would like to highlight is that, well, if she contributed to the photoelectric prize, to the photoelectric effect, so she deserves some recognition. And again, there was no recognition for marriage. Okay. The couple divorced in I think 1990, okay. And Einstein afterward got married with his one of his cousins. Before getting the divorce, Milena marriage reached an agreement with Einstein. And the agreement was that if he ever got the Nobel Prize, because she believed that the work they did was very important, then the money corresponding to the Nobel Prize will be for their sons, okay? And indeed, he got the prize in 1921 after they got divorced, okay? That money, she used it afterward to take care of the son, one of the sons she had with Einstein, Edward Einstein, who was schizophrenic, okay? So at the end, she helped the husband, Einstein, on his theories, and then she was the one that was taking care of the sons, okay? So here another example of, well, things that happen. And now let me, I would like to talk about two current scientists. One is Jocelyn Bell Vernon. She's an astrophysicist from Northern Ireland, sorry. She was the first to observe radio pulsar, and this was back in 1967 while she was doing her PhD. She was at that time a postgraduate student, okay? That was a huge advance for science, and it was worthy of a Nobel Prize in 1974. But she was not one of the recipients, and I put it there in red and in capital, despite that she was the first one, okay, to observe radio pulsars. Who got the Nobel Prize? Well, Anthony Hewish, who was her PhD supervisor, and Martin Ryle, who worked with Anthony Hewish, okay? Now, only 44 years later, after 1974, that is in 2018, her contribution, her observation of radio pulsar were recognized, and they were recognized through the Special Breakthrough Prize in Fundamental Physics. And as I said, I insist this was a recognition of her discovery of radio pulsars, okay? 44 years after the Nobel Prize of 1974. Well, not surprisingly, she donated the prize, the money of the prize, to fund women and the represented ethnic minority and refugee students to become researcher in physics, okay? That's impressive from her side, okay? So she made, I insist, the first observation of radio pulsar in 1976. Nobel Prize in 1974 was for that discovery. And although she was part of the paper, okay, in which the radio pulsar were discovered, she was not recipient of the prize, okay? Again, that's why the 11th of February is very important. It's the International Day of Women and Girl in Science, okay? And let me finish this short presentation by speaking about Andrea Mays, who got the Nobel Prize, a female scientist, the fourth female scientist that got the Nobel Prize in physics. This was back last year, 2020. So Andrea Mays is an American astrophysicist, as I wrote there, and she was awarded the Nobel Prize of 2020 in physics, together with Sir Roger Penrose and Reinhard Genzel. Roger Penrose got the Nobel Prize for his theoretical contribution with his theorem that states rigorously that black holes are solution of general relativity, while Andrea Mays and Reinhard Genzel got the Nobel Prize for the observation that indirectly inferred that there is a black hole Sagittarius A star at the center of our galaxy. Okay, so as I wrote there, general relativity predicts the existence of black hole. Now, the huge contribution of Andrea Mays is to indirectly observe the existence of a black hole at the center of our galaxy, the Milky Way. So essentially, Gay's work, part of it, is based on making observation of the center of our galaxy, the Milky Way, and it's where Sagittarius A star is located. Okay, so what Gaz and her team did was to observe the rotation of stars close to the center, okay? So how do these stars rotate around Sagittarius A star? Okay, so in particular, what they observed was the complete elliptical orbit of a star known as S2. So the experiment started back in 1995, roughly. So they could complete a whole orbit. Now, if you know where the star, what is the period of the full orbit, how much time does it take to make an orbit around Sagittarius A star, and do you know how far it is from the center of Sagittarius A star through the third Kepler law, you can infer the mass of the object at the middle, okay, Sagittarius A star. It turns out that it's too massive, and therefore it corresponds to a black hole, and in particular, a supermassive black hole, okay? So that's why she got the Nobel Prize. Okay, so it's, we know now that Sagittarius A star is a supermassive black hole sitting at the center of our galaxy, okay? Okay, so I presented briefly the work of 4 scientists, okay, and how things have improved along the last, say, 100 years or more, but things have still to improve. And insist that's why the 11th of February, the International Day of Women and Girl in Science, is so important. We all have the same rights, no matter of our gender, the same right to access science. Okay, so I hope you enjoyed this video, and see you on the coming video. So that's all for now. Bye.